Hyperscale Elastic Pools recently went generally available. Learn all about it and why you might use it and some other things you might not have known this week on Data Exposed. Hi, I'm Anna Hoffman, and welcome to this episode of Data Exposed. Today, I'm joined by Arvind. And Arvind, you've been on the show before, but it's been a really long time. So can you remind folks a little bit about what you do?
Great. Thank you, Anna, for having me here. And hello, everyone. I'm Arvind Shyamsundar. I'm a principal product manager at Microsoft. I work on a product called Hyperscale, which is part of the Azure SQL Database family. I wear Hyperscale on my sleeve, literally. That's what I do for a living. And I'm really excited to be here to talk about something that we made generally available today, very recently, which is called Hyperscale Elastic Pools.
Awesome. Cool. Well, we're excited to have you on the show. You're the exact right person to break this down for us. So let's get started. So I wanted to start by asking you a little bit about Hyperscale more generally. Like, why should people think about using Hyperscale, and is it only for really, really big databases?
So Hyperscale is SQL Server at the core, but it's also built ground up for the cloud. It's been out there for a while, and it's been really popular with a lot of workloads, like whether it's a new workload that you're bringing fresh to the cloud, or you're modernizing existing applications. It presents a cloud-native architecture that you can use to scale your application from whether it's 10 gigabytes of database to 100 terabytes of storage. It has some of the best performance that we can offer in Azure for relational workloads. And it also allows you to have some very unique capabilities like read scale out to offload read-only workloads. So much so that we believe that Azure SQL Hyperscale should be the only database that you consider for your cloud-native database development.
Awesome. Cool. This really helps kind of demystify the name and what it's for. Now, you mentioned we announced the GA of Hyperscale Elastic Pool. So what's a Hyperscale Elastic Pool?
Sure. Let's take this in the form of a real-life example, reduced to somewhat of a fictional walkthrough. So I'm going to use a character, kind of a journey that she has, and this is Tina, our fictional character. She's an architect at a startup called Wingtip. And Wingtip is actually developing an application for ticketing purposes. So this is things like concerts, sports events. Think of any kind of event that you want to issue tickets for. So Wingtip Tickets is what the name of the application is. And Tina is using Azure SQL Hyperscale because she knows how scalable it is and what kinds of features it offers to for easy development. She has used a very popular pattern called a single database per tenant pattern. So essentially what she has is a database for each of the events that she's essentially going to be providing these services for. So tenant 01, 02, and so on, each of these could be a different event that Wingtip Tickets is providing the ticketing kind of application services for. By putting each tenant's data in its own database, she ensures isolation because you don't want to have, ticket sales for one event being mixed up with another one. But then each of them also can be operated independently, so the application doesn't have to worry about things like multi-tenant, code and stuff like that. So simple. But easy to scale. As she adds more tenants, she just adds a new database and she's ready to go. So it's very easy to get started with Hyperscale Elastic Pools. It's completely supported in the Azure portal, as well as all other programmatic mechanisms, whether you use Azure PowerShell, CLI, T-SQL. So here we're going to walk through how Tina creates a new Hyperscale Elastic Pool. She clicks on the new Elastic Pool, gives it a name, changes the addition to Hyperscale, and then picks a size. So she's going to start with a 16 vCore size. The good news is she can right size this Elastic Pool vCore allocation after the fact. So she does that, clicks on create. It's typically a 2-minute or less operation to create a new hyperscale elastic pool.
Awesome.
Now, fast forward, the pool is created. One of the important things that you would want to do, and which Tina also does in this case, is to set a policy. And if you think about it, whenever you're resource sharing, whenever you're pooling things together, it's important to set limits. It's important to set a quota of sorts saying, hey, I want to ensure that no single database in the pool goes and uses all the resources in the pool. So Tina does this by using the Elastic database settings on the hyperscale Elastic pool. When she clicks on that, she can then slide this essentially up or down. In this case, she picks a policy saying no database in the pool is allowed to use more than 4 vCores. This allows her to efficiently manage runaway database kind of scenarios where there's a particularly busy database. You don't want to have that bring down the rest of the database in the pool. So highly recommended whenever you're working with hyperscale elastic pools, set the per database maximum to something that you think is reasonably adequate, but at the same time, kind of like a finite limit as well on how much resources are being allocated to that particular database. Creating databases in the pool is also very easy. You go to the pool and then you click create database. All that you have to do is to give it a name essentially and pick things like storage redundancy. You don't have to manage the vCore allocations to individual databases because remember, it's part of the pool. So it inherits essentially the configuration of the pool and those per database maximum settings that we earlier talked about. I'm going to fast forward again. Tina and her team are very busy. They have actually launched this application. They have multiple tenants. In this particular pool, let's imagine that they have 8 databases and some ticket sales are going on. It's preparing for the holiday season maybe. And they find that the resource usage on the hyperscale elastic pool has gone up. In this case, it's gone up to like 90% of CPU usage. The great news with hyperscale elastic pool is that such scenarios are easy to handle. Like operationally, you can scale up the pool in response to high resource usage events like this, scale it up and let the event kind of do what it needs to do, give it the resources that it needs to get, and then you can right size the allocation back down again after the fact. So to scale the pool, you go to configure. So you kind of click the configure option there and you go down. And in this case, Tina and her team kind of scale that pool to 24 vCores, which they think should be adequate to get over this peak usage scenario that's being observed for this pool. So as you can see, kind of again, pool scaling operations are more or less constant time. Typically takes on the order of a minute to 2 minutes, regardless of the size of the data in the pool. This is huge because if you had tried to scale a database previously with something other than hyperscale, sometimes you have to copy data around because the operation has to find a new place in the cloud to have that database hosted. And then you have to wait for the time that it takes to copy that data around. And that's not the case with hyperscale because the storage and the compute are decoupled. The scaling operation is almost always a matter of minutes. Fast forward again, after they finish scaling the pool, they find that the CPU usage on the pool is a lot more tolerable. It's at 65%. CPU usage. What I'm showing to you here is also a view called the metrics view. Each pool can be monitored in isolation. You can have a lot of details like the percentage of data I/O, the CPU usage, how much storage, how much data I/O is happening on the pool, etc., etc. So lots of details. While we make it very convenient for you to work with the hyperscale elastic pool, we are also giving you all the power behind the scenes to be able to administer it a lot more in detail. Last but not the least, as Tina's application gets more popular, the size of data stored across all these databases in the pool keeps growing. One of the best things about hyperscale is you don't have to allocate storage as your needs grow. Hyperscale grows as you as your applications grow as well. In this case, you can see that hyperscale elastic pool that Tina started with has actually grown to 17.8 terabytes in size. So this is super cool because you don't have to then manage or micromanage the allocation of storage to each database in the pool. You just kind of put the databases in there, allow them to grow. Up to 100 terabytes at this point in time is supported in a single elastic pool. And as the saying goes, that should be plenty for everybody, but we'll see how far that gets us.
Awesome. Cool. Well, thanks so much, Arvind. This was super great to kind of walk through this scenario and see what it looks like in real code and real deployment. So thanks for doing that. As we close out, any call to actions or advice for folks of things they should do as they get started?
Sure. I want to talk about one of the really useful features, which is unique to hyperscale elastic pools, and then I'll kind of leave you with a few trailing thoughts. Let's take, again, the case of Tina and her application, Wingtip Tickets. Wingtip Tickets has been growing widely popular. They are adding new functionality every few months. With riding the AI wave, one of the things that Wingtip Tickets wants to add is analytics and AI kind of module. Tina knows what she wants to do because with Azure SQL, she gets a lot of bleeding edge AI support features, but she's a little worried about using the database's primary replica for those new functionality. The cool thing is with Hyperscale, we offer virtually unlimited read scale out. At the pool level, you can add up to 4 high availability secondary replicas. So this is the primary pool plus 4 secondary replicas of the pool itself. This is a unique capability which we only make available with hyperscale elastic pools. So this way, all read-only workloads can then be redirected to those high availability replicas, leading Tina and her team to offload all of that processing to those replicas. This is done without duplicating storage. So all that she needs to do is literally go to the pool, click on configure, and if you caught this at the beginning of there's a little slider there for high availability secondary pool replicas. In this hypothetical example, Tina decides to add 1 replica to start with. She can go all the way up to 4. And then when her application needs to read data from those replicas, all that it takes is a connection string attribute, which can then allow the read-only queries to go to that replica. Again, no duplication of storage. You still share the same decoupled storage architecture that Hyperscale has, and all the compute then is used from the secondary pool replica. So this was just a kind of a quick synopsis of all the nice things that you can do with Hyperscale. It's great cloud native capabilities, leading edge performance at one of the best price points that you can get in the cloud for relational databases. I would just ask you to try Hyperscale out, and with Hyperscale elastic pools, as you grow, as you add more databases to your fleet, you remain cost efficient, and you don't have to worry about performance at an individual database level. By pooling things together, you kind of work with the economy of scale, as I've said many times already. Do try out Hyperscale elastic pools. Tina is extremely happy, and we believe you will be even more happy once you try out Hyperscale elastic pools. Product documentation, very easy to find, aka.ms/HSEP. And for more information, if you want to have more dialogue with us, we would love to hear from you. You can reach us through the SQL database feedback page, or if you'd like to email us, we would love to hear from you at sqlhsfeedback@microsoft.com. Thank you again, and we hope that you can try out Hyperscale elastic pools sometime soon.
Awesome. Thanks so much, Arvind. And we should also probably thank Tina for her hard work here and success. To our viewers, if you like this episode, go ahead and give it a like, leave us a comment, let us know what you think. We'll put links in the description for you to learn more or to reach out directly to the Hyperscale team. And we hope to see you next time on Data Exposed.